Okay, the project which we started last time was predicting fuel efficiency of vehicle. There are 7 steps which we will be discussing in this particular, you can say, project. The first step was a data collection, and as I told you, data will be provided to you by either the vendor who's giving you the project, or even you can go ahead and collect the data. But the most important thing is checking the data, whether the data is as per our requirement, then finding out the different types of data types which are there in the data. Secondly, whether we have some column headings, some description about the data, all that matters. So when we are actually looking at the data, we have to analyze what type of data we have, whether it has some null values in it. If there are missing values, then replacing it with some, you can say, relevant value. Either you can use mean or median or any other value which you want to replace it with. It's up to the person how he decides. Secondly, we defined the problem. And as you said, if you remember, while defining this problem statement, in this example, the data which we saw contains a variable called MPG, which is miles per gallon, okay, which is a continuous data. And it tells us about the efficiency of fuel consumption of the vehicles which were there. And now the vehicles data which we have is of 70s and 80s and not the recent data. Now, our aim here is to just predict the miles per gallon value for a vehicle given. And we have the other attributes that can help us find out or predict this MPG value. Okay. Now, to just find out whether there's any correlationship between any other attributes and MPG, we went through the data. So if you remember, we created the columns first. Okay. We read the CSV file and we assigned the columns because the original data did not have the column headings. So we have added the column headings. The NA values were represented by a question mark. So we have given this parameter NA underscore values equal to the question mark in double quotes. And there was one more column at the end. There were totally 9 columns. The 9th column after the tab was a comment. So we have given this parameter comment equal to /t as well. Okay. And this CSV file do not have comma as the separator. It has space as the separator. So we have indicated this parameter SEP equal to, in double quotes, we have specified the space, single space. Okay. Now this data frame which we got in DF, we copied it and created a new copy called data. And using the head, and we can also make use of the sample function to check the content of the data, how it is displaying, and you can just have a view of the data, how it looks like. Now there's another function which I showed you was the sample function. Now the sample function is better than the head function because it's going to randomly pick up some records from the data set or the data frame which we have created and display the data. It will give you the overall picture of the, you can see the population whose data you have collected. Okay. Then we went to the third step, your exploratory data analysis part, EDA. And there are some function I showed you, the info function, which gives you the idea of how many records we have and what are the different number of records available for each column and their data types. And we saw this whole thing. You can see this column headings. Okay, and these are the number of records we have, and we immediately knew that there's some null values for this particular variable here, your column horsepower. And we also understood that the different data types for each column. Okay, and as you can see, all of them are numerical values. Either you have the float value or the integer values. Okay, then we tried to find out what are the different null values, the total null values for different columns for the data frame, where we use the function is null. And because we wanted not true false, we wanted the sum. So we used the sum function, and it gave me the details of the null values in each column. Okay, and you can see this. There are 6 null values in the column here, horsepower. Then we use the description function to see some statistical values which are calculated. So, and this T indicates transpose. So I've just converted the rows into columns and the columns into rows to see you can say description in a better way. Okay. And from this information, we especially refer to the minimum value, the maximum value, and the different quantiles of the record, that is 25%, 50%, and 75%. This is by default given to you. But if you want to check the different percentile or the quantiles, you can easily do that, which we did down here somewhere. So here you can see this was the quantiles which we saw. We saw 50%, 90%, and 98%. Okay. Why did we see especially for the horsepower was because we found that when we plotted the box plot, you can actually plot any scattered plot also. We plotted a box plot, and we saw there were some outliers here which we wanted to remove, and we wanted to check what is the quantile as it is right skewed. We found that beyond, I think, 98% was 210. If I change this to 97%, okay, it was 198. So this line, this is my whisker, the end is coming around 200. So we decided it will be better if I ignore or remove this outliers and then work on the data. Okay, that was the brief, you can say, conclusion. We did not actually remove the outliers, and we went ahead. We saw the median value. We removed the median of horsepower because we wanted to fill the null values. So we made use of the fill null or fill any function with median. So later on, when we displayed the information, the brief information, we saw that all the values are now filled. Okay, so we do not have any null values anymore. Okay. Then we went ahead and we saw the distribution, you can say the distribution of the variable cylinders. Now, cylinders is your categorical variable or value or column. Okay, so we tried to see how the values are distributed in case of cylinder. So we used the function value underscore counts, and then we divided that by the total number of records. I did not give the constant. If you remember, I had given the constant as well. So we gave 398. That was the total number of records which we had. And we saw the values here. So if you look at the counts, especially for the origin, you'll find we have 62% of the records belonging to the origin one. And as I told you, again, this is a categorical data, and one represents India, 2 is for USA, and 3 is for Germany. So we have very less record of the other 2 origins. You can see only 0.17, 17% and 20% records. The majority of the data is coming from India. Okay. Now, I told you we should not give this constant value. Instead of giving the constant value, we can make use of the length function. Reason because if suppose my data changes or the number of record changes, I need not go and make the change in change the constant value. Okay, and there's the reason we made use of the length function, len length function. Then we plotted the pair plot. Now, because we did not want all the variables. Now we have 8 columns. If you look at this, we have total 8 columns here. I do not want to plot all the 8 by 8, you can say, plot. Okay, so what we did, we selected some few columns on which I want to check my pair plot. And one more thing, what you can do is when we saw this, we did not see the correlation actually. Okay, through this we decided which are the, you can say, fields on which I would like to do some more further research or some further analysis. Okay, once we used this pair plot, then we saw the different plots, scattered plot, plus we also have this. Now, the ones which are in the diagonal are based on, you can say this can be either you can say a histogram or some other type of a plot. Now, this is your KD, the curve, because we have given diagonal kind equals to KD, and that's why we are getting the KD graph in the diagonal. Okay, this is MPG versus MPG. The x-axis, you'll find this MPG here. Now you will say that why did we, or whether it is required. Now what is this particular graph representing? This actually gives you the total count, you can say. If I do not want, if I change this, let me change this one. Okay. Now you can see this is my histogram, which has been plotted because I've removed that KD option which we had given. Now this histogram represents the number of counts, you can say, for a particular mileage. So if the mileage, say, let us say 10. So how many values do I have with the value 10? That is what it is representing. Okay, and that's why it is not a straight 45-degree line, you can say. It is not giving you the lines. Whereas if you look at the other plots, like especially the plots where we have huge correlationship, especially you can see this displacement versus the last one. What is the last one here? Weight. Okay, there's a huge correlationship. Then horsepower versus weight, there's a relationship. Horsepower and displacement has a relationship. Then mileage and even horsepower has, and the weight has some relationship there. Okay. Now you can also see some graphs which is having some plots like this in a line, one line. Now these are nothing but your categorical datas. Okay. So if what is this? The second one. Second one is cylinder. Yes, it is cylinder. So you can see this. Because as I said, cylinders and your origin is again your, you can say, categorical data. We also have the other variable, which is the other variable which is categorical here. No, none of them. Even horsepower you can consider if it is horsepower versus okay. And then we went ahead and we decided we will go through some of the variables. We'll refer to those variables and then perform our analysis. Okay, that is the brief about what we did last time. Now, when we are talking about testing a model or training the model, basically what happens is whenever we have a particular model which is designed, first thing what we do is, especially in case of supervised learning, we actually supervised learning is one way of machine learning. Okay, there are basically three: supervised, unsupervised, and enforcement learning. So basically, when we are doing or when we are talking about regressions, or you can say other decision tree and all, we are actually talking about you can say supervised learning. In supervised learning, what happens is we actually test the data, and before that, we train it with some data. So one thing remember is whatever data you get. Now, I have a very small data set here, which is having only 398 records. Basically, when you work with the real world problems, you will be working with, records of, millions of records where, you'll be getting it and you have to filter it and whatnot you have to do. You have to actually go through the whole process of cleaning your data, checking the data and everything. Plus, you should not provide all the data for training to the model, because what will happen is the model will, understand all the data which is available, and then when you're testing it, it might not give you the right, you can say, or it might give you the perfect information. That means it is literally overfitting. It is known as overfitting of the model, which should not happen. There should not be an error of, okay, you can say zero or such, something like that. So if you have some data which is there, see that you segregate or split the data into two different, data frames, one for training and the other one for testing. Okay. Now, basically, the rule which is followed by everyone, which is also mentioned by many of them, is the test data should be 20% of your overall data. So 80% of the data should be used for training and 20% of the data should go for testing purpose. Now to do that, there are different ways of doing it. Now I'll just show you some simple code where we are setting aside. So if I have to set aside, let us say setting aside test data or test set, let us say this. Okay, if I want to do this, okay, first of all, I'll require the sklearn package from where I can import the train test split, you can say class, which is a part of sklearn.model selection. So first of all, let us import that. So I'll say from sklearn dot model underscore selection. Okay, import. The name of the class here is train test split. Okay, that is, I'm pressing tab to get the values, the help. Okay, now for this, there's a function under this, the split function for the class, which I'll be using here. So I'll get two different types of, you can say, data set, and we can check the values as well. So I'll create two variables, trend set, and I'll have a test set. Okay, two sets. I'll write equal to train underscore test split into bracket. Now the data which I want to split is in a particular data frame. The name of the data frame is data. So I'll give you a data, comma. Now there are two more parameters which can be given. One is your test size and your train size. Now by default, if I give one of them, the other one will be decided on its own. So you need not give both simultaneously. You can give one of them. So as I said, the test data or the test size should be 20% of the data. So the test size will be given as equal to 0.20. Okay, that is nothing but your 20%. You can also specify the train size, but because we have already given 20% there, the remaining will be treated as your train, you can say, test set. Clear? Then one more thing we need to give here is this one variable. Or before that, I'll just complete this whole thing. Okay, we'll press enter and we'll try to display the value of the train set. Or let us give the test, because there is 20 records. So test set, we are going to display this. Okay, here we go. You can see this values. There's some 80 rows has been divided, and the data has been split into two sets. Okay, now when I run this again, just observe the records here. So we have here the index position 211, 192, and so on. Now let me run this again. Okay, now when I run it again, what happens? My test data, the data changes. Okay, why? Because it is randomly picking up the records. Now what happens is, if you keep on running this n number of times, time will come when the train set, especially the train set, will have all the records. Okay, it will refer to all the records, and the model will be able to learn from that given data set. So all the records, if all the records are available for training to the model, then it is not the right thing. Okay, I need to stick to the records which I have fetched, and those records means these records which I have should not change when I'm running n number of times again and again. Now to fix that, I need to give one more parameter here. So I give a comma here and I write random state equal to, so it's random underscore state equal to 42. Okay. Now, if you want to know what this exactly this 42 indicates, or there's another value 0 or 42 is used. Now, in this case, I do not want the numbers or the records to change again and again if I'm running or executing this particular code n number of times. So when I run this now, okay, now I got this first record as say 198, then 396, and so on. Now let me run this again and check whether this record changes. No, it is not changing. Okay, and that is what I wanted. Clear? So remember, do not, create the split such that, this, especially this random state equal to 42 is not given. Otherwise, what will happen is the model will get all the data somehow. It will take 80% first. Then when you're running again, might be the ones which were not there previously will be a part of the train data or the train set. And then again, it will work on that. And so it actually knows all the values. Okay, that should not happen. Clear? So for that, you need to give this parameter. This parameter is very important. Now going ahead, I can check you can see the number of records which you have and the distribution as well for you can see different variables. Now the most important distribution which I would like to see is of cylinder. Now before that, let me check this shape. So test. So instead of the record, instead of the set here, what I'll do is I'll display the shape so that I get some space here. Okay, so we have 80, you can see rows and 8 columns. Next, I'll just check the value counts for the train set to know what exactly how they have bifurcated or splitted the data, especially for cylinder dot value count. It's a function. And as I told you, if I want to know the distribution, I can put the division sign slash and the length of the train set. Okay, this will give me the distribution. If I do not give this, it will give me the record. So even I can remove this and check the count as well. This will give me the count. Okay. Now, if you look at the train set here, I also want to know. Now it has taken lots of data from this cylinder with cylinder 4 as value, categorical data 4. Then if you look at the percentage, let me check in percentage so that we can. So 50% of the records belong to cylinder 4, then 24%, 22%, and 0.1. And this is very less, which is 0.009. We can also check, similarly, we can check the test set. So I will just copy this whole thing. This. Okay, now there's a problem here. You can see this while taking the data, it is taken only for values of 4, 8, and 6. Okay, whereas 3 and 5 has been ignored because I think the full data is coming in the trained set here. And in the test set, we do not have any value to test for cylinders 3 and 5. Okay. Now, again, you can see this is not properly done. It is not equally picking up the samples, you can say, for training plus for testing. Okay. So this is a problem here. Now, why it is a problem? I'll just try to explain you this further. Now, let us say you have a huge population based on which you are collecting some information and trying to find out the data or trying to find out some conclusion. Okay, let us take a simple example. If suppose you want to find the preference of different, people, uh, especially related to social media, what the platform they prefer using, and you're collecting only data from the population, you're focusing only on people who are of the age, say, greater than, say, 50. Okay. Now, if all my sample data, from all the sample data, if my test data or my train data is not picking up the data properly from the different categories, you can say, age categories, what is going to happen is it is going to give me a sample such that, it won't be able to predict the data for the other age group. Okay. Now, if all my data is for above 50, okay, whether it will be able to recognize the prediction, whether it will be able to predict uh, you can say preferences of people who are below, say, in the range of say 20 and 30. It won't happen. So while giving the data for testing or for training to the model, you should see that it contains different types of data. So from each, you can say, bracket or category, you need to provide some data to the model so that it gets trained on that particular data which is available to us, so that when we are actually doing the testing or trying to do the prediction, it is able to recognize that category of data and try to give and definitely give us a better result overall. So while splitting the data, this is not the best way of splitting the data. Okay, using your train test split function, this is not the best way of doing it. So which is the best way? The best way is a stratified sampling. Now, what is stratified sampling? It is actually a sampling method from the population which partitions your population into subpopulations. Now, when it's actually doing that, it sees that it take care of all the categories of data. So my the sample data which I have, or the subpopulation which we have got through stratified sampling, will actually represent the overall population. That is the whole purpose. Okay. So to do that, I'll be using some other class, which is stratified shuffle split, and I won't be using the train test split. Okay. Now, if you have a data where everything, the data itself is equally divided, for especially in this case cylinders, because my data is not equally divided among all the different types or categories of cylinders, I need to make use of this stratified shuffle split. Okay, now let us see the code for that. Now, again, I'll be importing this from sklearn. So sklearn.model selection, import stratified shuffle split. Okay, this is what I'll be using now. Now, in this, first of all, let me again the test size, as I said, will be 0.2, and I want to split this into a single split. That means I want only one, you can say, subpopulation. I don't know how want multiple subpopulation. If you want, you can also create, suppose you have millions of record and you want to create small different subsets, and then you want to do some you can say training and then testing. You can do that as well. In this case, I'll be creating only a single split. So to do that, I'll be creating, let us say I'll use a variable SPL, or you can put it as split equal to stratified shuffle split into round brackets n underscore splits equal to 1. Okay, so I want only one set of this. The test size, I'll keep it as 0.2, that is 20%. Okay, or you can give 0.20 as well, or 2 will also do, comma. Now, again, remember that a random state equal to 42, that is again important here. So random underscore state equal to 42. Okay. Now, once we do this, we are going to get the indexes. Now, I have to get the data as well. Now, the data has to be stored in two different variables. That is your train strat train set. I'll be creating two different variables now using a for loop. So I'll have for loop for train index, comma, test underscore index in SPL dot. Now this is going to split it. So split is the function. SPL split the data based on what that I need to give. So data is my data frame, comma, I want to split it on the variable cylinder or the column cylinders. Okay. Now this will return the index positions. Now from this index positions, I'll be storing this data into a different data frame. So we'll create a train set again. Now we already had train set here, so I'll change this to say stratified. So let us say strat underscore train set. Okay, this is equal to, now how do I refer to the record? I can use the log function or the ilog function if you want. I'll use the log function, LOC. I hope you remember this function, and we specify the train index. So train index will come here. This record will be added. As I also want to do it for the test index. So we'll create a test set equal to data dot LOC in the square bracket test index. Okay, so let me run this one. Okay, there's no error as such. So let me check the shape now. So whether it has got the records, say test set dot shape. Okay, what happened? Test strat is not defined. strat test set. Why it is not defined? Did it execute this properly? Look at this. No. Let me try here only. Strat strat test set dot slash shape. Okay, it's giving me now. So you can see this 80 records and 8 columns here. Now, if I want to know, let us check for the counts. So we can see the distribution now. So if I want to check the distribution, again, I'll be using the same function which we did here. So let me copy this one and paste it here. And instead of this, strat underscore test set cylinders, and here also it will be strat underscore. Fine. Now if you look at the distribution, now we have got 4, 8, 6, 3, but still 5 is missing. 5 has not been done, but this is much better. And if I want to refer to the train set, so again I'll copy this one and change this to train. Okay, and now you can see this 51%, 25%, 20, and so on. Okay, this is much better compared to the previous one. Okay, where my train set and even your test set has got you can say properly distributed. So you can see this in the train set we had 50%, then 24, 21, 0.01. Here we have 51%, 26%, 21%, and here we have 1% something. Similarly, here also you can see this has been equally, you can see this 51, so this is also 51 somewhere. This 25, this 26, it's okay, 21, 21. Now for 3, it is 0.09, it is 0.01. Fine. Clear? Now, this is how we can actually, make use of the stratified sampling method so that we get the proper data for training as well as testing. Let's go ahead and check. We'll try to convert the origin column. The origin column has 1, 2, 3 there. We will try to convert the integer class into the name of the countries. So we can do this. So we can use train set. I'm using train set now here. You can use the stratified as well. Let me use train set here. The name of the column was origin equal to. I'm just showing you how to do it and how the data looks like. I'm not fidgeting with the strat train set. We will need that data again. So we'll be working on it. Now there's a function called map, which can be used to convert your integer class, that is your numbers 1, 2, and 3, which is your integer class, into a string class. Okay, so I'll change this into some names. So one will be represented by, say, India. So the function is map function, which we'll be using, and the parameter which I'll be passing will be a dictionary. So I need to put it in the curly brackets. So 1 is my value. I want to represent or replace this with India. Okay, and comma 2, I want to change it to USA. And the third one, I want to put Germany. Okay, and then I can also say, let's run this. Fine. And we can leave train underscore set dot sample. Say I want only 10. Okay. Now, as you can see this, now it has been converted. The origin has been converted. The integer class is converted to your values now, with string values. Clear? Now, this string values has to be further encoded. Okay. So we need to perform some encoding here. Now, what is encoding? Okay, if we have, there's a concept called one-hot encoding. So all your values has to be encoded into a relevant data. Okay, and it has to get some values. Now, there are two things which need to be done. One is encoding each data so that it is a similar type of data are available to you, which is a part of your data preparation. Okay, so what we are going to do is, let us go ahead and do the encoding. I'll just show you how to do it first, and when we actually do it for the main data. So this is your one-hot encoding. Okay, it is, say, I'm doing it on the train set. So what is going to happen is this will be encoded into 3 different column sets. Let us do and check it out how it looks like. So pd dot, this function, it is available in pandas. So pd dot get dummies, okay, into bracket, which I want to encode the train set. Then I need to give the prefix. So this is not there, prefix equal to, say, single quotes, comma, and the separator also has to be a, say, prefix separator equal to. And now when I display the value, so train set dot, let us use head. Okay, now you can see this has been encoded now. So your origin, which was a categorical data, has been encoded into, so Germany, India, and USA. Wherever it is true, we get 1, else we get 0. Okay, this is how it works. Fine. Why we need to do this is when we are doing any, you can say, analysis, it should be in a better code format and not as strings or so on. Okay. Now what we'll do is we'll copy this the previous data which we had, that is the strat train set. we are going to actually work on that. So I'll copy that to a new data frame, which I'll be working on. So I'll say data equal to strat underscore train set dot copy, and I'll work on this. So my original data, that is your strat train set, remains as it is. Okay. Now let us use this information and check the correlation matrix so that we can find out which are the columns which I would like to refer to. Okay, so to check the correlation, I can create a correlation matrix which is equal to the data name plus CORR. Okay, and if I want to display this for underscore matrix, now I'm not going to display the whole matrix. I want to refer to